Hello friends, today we will try to learn the concept of degree of unsaturation, which is also called as index of hydrogen deficiency or a site of unsaturation. This concept is found to be useful when you are deducing the structure of organic molecule from spectral data. Before that, let us see what is meant by saturated and unsaturated hydrocarbon. On the screen, you are observing the structure of N-butane, which has the molecular formula C4H10. It belongs to the family of saturated hydrocarbon, which is also called as alkane, with the molecular formula CnH2n plus 2. You can generate library of different alkanes by substituting different value for the N. As valency of carbon is 4, you cannot add more hydrogen in this formula. So degree of unsaturation is 0 for N-butane. You are also observing the structure of 2-butene, which contain one double bond. If you compare with the N-butane, 2-butene will have 2 hydrogen less. So the point to be remembered, if you have one site of unsaturation, you have to lose 2 hydrogen. Next structure is cyclobutene, which contain carbon-carbon double bond as well as the one ring. Its molecular formula is C4H6. If we compare the molecular formula of cyclobutene with the butene, you will see there are 4 hydrogens are less. That means cyclobutene will have 2 sites of unsaturation. So unsaturated hydrocarbon should contain double bond, triple bond or a ring. If any of the bond we are replacing to double bond or a ring or a triple bond, there will be deficiency of hydrogen, which we call as a index of hydrogen deficiency. So please remember, one butene has 2 hydrogen less if you want to convert into butane. Therefore, butene has 1 degree of unsaturation, while cyclobutene has 4 hydrogen less as compared to the butane. Therefore, degree of unsaturation of cyclobutene is 2. Let us see how to calculate degree of unsaturation of organic molecule containing heteroatoms like nitrogen, sulfur, oxygen, halogen. You have to apply 3 rules. Rule number 1, if molecular formula contain halogen, you have to replace all the halogen atoms with hydrogen atoms. If molecular formula contains oxygen or sulfur, omit oxygen and sulfur. If molecular formula contains nitrogen, remove the nitrogen along with 1 hydrogen atom for each nitrogen atom. By applying these 3 rules, you will get a simplified new molecular formula that has to be compared with the saturated hydrocarbon analog. The difference between the number of hydrogen atoms will give you a degree of unsaturation. Let us see the first example with molecular formula C4H7 chlorine atom. By applying rule number 1, chlorine will be replaced by 1 hydrogen atom. You will get new molecular formula C4H8. The molecular formula of saturated hydrocarbon with 4 carbon is C4H10. In order to calculate degree of unsaturation, you have to look at the hydrogen number of saturated analog and newly generated analog. The difference between these two numbers will give you the deficiency of hydrogen atoms. Here in this case it's a 2. Degree of unsaturation you can calculate simply by taking the difference divided by 2, which gives the degree of unsaturation 1. The molecule may have one carbon-carbon bond or one ring. Let us see next example with molecular formula C5H7, 1 bromine and 2 oxygen. By applying the first rule, Br is replaced by one hydrogen atom. By applying second rule, we will omit oxygen so that newly generated formula will be C5H8. The molecular formula of saturated hydrocarbon with 5 carbon is C5H12. We will take the hydrogens which are present in a saturated analog and newly generated formula. The difference is 4 hydrogen, which will give the degree of unsaturation 2, which may accommodate carbon-carbon double bond, carbon-carbon triple bond, carbonyl bond or by ring. Let us see the next example with molecular formula C8H8, 1 chlorine, 2 nitrogen and 2 oxygen. By applying all the 3 rules, you will generate new molecular formula C8H6. The molecular formula of saturated hydrocarbon which contain 8 carbon is C8H18. We will take the difference of hydrogen number of saturated analog and newly generated molecular formula, which is 18 hydrogen minus 6 hydrogen. 12 hydrogen is less. So degree of unsaturation is 12 divided by 2. It gives the answer 6. A degree of unsaturation equal to or greater than 4 indicate the possibility of one aromatic ring along with carbon-carbon double bond, carbonyl group or carbon-carbon triple bond. I hope this video will help you to understand the concept of degree of unsaturation. Thanking you.